Alright, so today we're going to be working on adding and subtracting polynomials. So let's just review how would we simplify these two up top here. Well, it's really just simply combining like terms, where I add my 3x and my negative 5x to get negative 2x, and 2 minus 4 to get negative 2. I also over here can only combine things that have the same variable, so I can only combine my negative 2x and 7x to make 5x. And then the 4y and then the negative 9. I can't do anything with those, so I just rewrite those on the bottom. And there you have it. Now, when I throw polynomials at you, where I'm throwing in squareds and cubes and maybe different terms, it's the same thing, where I can only add them if they are like terms. So if we look here, if I do 3x squared plus 2x squared, I get 5x squared. Now notice the exponent does not change. When I'm adding them together, the exponent stays the same. That nothing changes there. The only thing that changes is the coefficient in front when I'm adding them. So 3x squared minus 5x squared gives me negative 2x squared. Okay, so let's try a couple that are a little harder. Down here where I have 3x squared minus 4x plus 2 plus 8x. Well, now again, I'm looking for what is like terms. Well, 3x squared, they all do have x's, so if I look here, my 3x squared has an x, my negative 4 has an x. But the only ones that are like terms are my negative 4x and my 8x. 3x squared is not a like term because the exponent is different. The exponents must be the same in order to combine them. So I'd have 3x squared plus 4x plus 2. Same thing over here. The exponents have to be the same. So 19y to the third and negative 2y to the third becomes 17y to the third. Negative 8x to the third just stays negative 8x to the third. And then 19x and 14x give me a positive 33x. Okay, for the last example on this page, we're subtracting a total polynomial. So just like you would think to do with any other problem where you're combining like terms, if I'm subtracting this whole second half here, I want to distribute this negative sign into each and every term. So I would have a 3x squared y minus 4xy squared plus 2xy plus 8x squared y squared minus 9xy minus 6x squared y squared plus 12x squared y minus 20x y squared. So all I did was distribute that negative sign to each, and now I'm going to combine like times referred. Again, the exponents have to be the same exact thing. So if I look here, 3x squared y, the only other one that is similar to that is 12x squared y. My negative 4xy squared, the only thing that is similar to that is this negative 20xy squared. My 2xy and negative 9xy are similar. And then my negative 8x squared y squared and negative 6x squared y squared, those are similar too. So now if I combined all of those, and I have the color codes up here, I'm going to get 15x squared y. Then I'm going to get a negative 24xy squared, a negative 7xy, and then finally a positive 2x squared y squared. So I have a few more examples here on the back for us to try. Again, you should try these on your own first and then check your answers as we go here, but I'll fill them in. So the first one here, if I combine those, I'd get a negative 4x to the fourth plus x to the third. The next one, I would want to distribute that negative first. So I have 3x minus 5x squared plus 4x to the third minus 10x squared minus 7x plus 2x to the third. And then I could simplify that to then be negative 4x, negative 15x squared, and then a positive 6x to the third. Going down here, here's some more. We can try again. The exponents have to be the exact same in order to combine them. So I can make this 4x squared y. I can have plus 14x and then minus 8y. And I got two more left here. I'll zoom out to do the last one here. But for this one right here, again, I look to see what's similar. I'd have a 5x squared y. Okay, because I can only combine these two because the exponents are the exact same. Plus 4xy squared minus 8, and then plus 5x. Okay, so now let's look at the last one. This is kind of my challenge one for everyone. Is now I'm not only throwing subtracting 1, I'm actually subtracting two different terms from this. So I'd have to distribute this negative each side over here to every last one. Okay, so that's what really makes this one so difficult. But then I'm left with negative 5 p to the fourth minus 2 minus 6p plus 5p squared minus 2p to the third plus p plus 3 plus 7p squared plus 2p plus 5 plus 2p squared, because I'm just distributing that negative to each and every term. And the last thing I just need to do is combine any like terms that I see. Well, I'm going to go through and do each one. So we'll start with the p's to the fourth. Well, I have 1p to the fourth, negative 5p to the fourth there, and that's my only one. So I'd have a negative 5p to the fourth. Okay, now I'll look at my numbers. Negative 2, 3, and 5. So if I can combine those, I would get 6. Then I got a negative 6p, a 2p, and a p. So that really gives me negative 3p. I got a 5p squared, a 7p squared, and a 2p squared. So if I add those together, I get 14p squared. And then the last one I have left is minus 2p to the third. So I want you to go through and finish your homework, the sheet that is attached, and then I want to make sure you turn in that identifying polynomial sheet, and I will look at that and give it back to you by Wednesday on the block day.